Let's get started by thinking about the clustered index of a table. Now, during this training, I'm going to be using the users table and other tables from the Stack Overflow Creative Commons data dump export. It's a whole lot of words. All it is that Stack Overflow makes their database available publicly for anyone to download. You can go get it and play with it inside SQL Server. I teach you how at brentozar.com/go/engine. I'm going to start off by looking at the users table, which is a list of everyone who's ever asked or answered a question on Stack Overflow, posted a comment, etc. Now, the users table, the clustered index, is on one field. Notice the key next to the ID field. This is exactly what you think it is, an identity field that starts at 1 and goes up to a bazillion, or however many users they have today. Now, the clustered index is only on one field in this case, but it actually has all of the fields in the table. Now, if you go to brentozar.com/go/engine, you did your homework, you printed out these PDFs, you can see what the clustered index looks like. This is the first 4 pages, the white pages of the PDF. Now, the first thing you'll notice is going down the left-hand side there, that's the ID field. Starts at 1 and goes up to whatever. That's the clustered index key, but the clustered index also includes the rest of the fields on here, display name, age, about me, etc. Well, not really, because look at the about me field. About me is a large varchar max or nvarchar max where people can write whatever they want, their big long resumes about all the things they're proud of. They can dump all of that stuff in the about me field. That is bigger than what we would allow on an 8K page. See, everything that SQL Server does is stored in 8K pages. And sometimes the stuff won't fit on a page, so we put that somewhere else. That's the About Me field going down the side. I'm not going to go into off-row data like these big varchar max fields early on. We'll cover that in a later module. The thing I want you to take away is it's not like varchar max and nvarchar max are free. Just because you can add them like willy-nilly doesn't mean they don't have a performance impact. Because when you want to go get that data, we have to go grab it from the other pages. The narrower we keep our data, the more likely we are to keep it on page and be able to see it right here and then without a lookup. So am I really lying to you? Is that really how SQL Server works? Well, you can go see for yourself with the command DBCC IND. This lists all of a table's pages. So I'm passed in here, Stack Overflow is the database, users is the table, -1 is a parameter that'll show me data for all of the indexes. And I can see those right down there. Here's the list of 8K pages that we have. And if I want to read those, I can use the command DBCC page, where I pass in, here's the database I want, here's the file that I want, here's the page number, and here's the type of information I want about that page. And this certainly isn't something that I expect you to ever do. Whether you're a developer, a database administrator, performance tuner, I don't expect you to go look at the contents of pages. But it's so neat to see the kinds of things that SQL Server stores in the header or on the page itself. Now, for most of the rest of this class, I'm not going to be talking about what's in the header because you really don't have to worry about that when you're just getting started. We'll leave that for later. But if you scroll down through DBCC page results, you can see that it actually contains the real data on the table. For example, this one user here, Andy N, has one of my favorite bios that I've seen on Stack Exchange. Watching progress bars for money since 1994. It's a pretty catchy bio. So for the rest of this training, you are going to be SQL Server and you're going to be managing this table. I'm going to be an end user that's sending you queries, and you have to figure out how you're going to build those results. Later on in other modules, I'm going to give you additional copies of this table, but right now this is the only copy that you have to work with, is that clustered index, because you as a SQL Server, your DBA sucks, and he hasn't given you any additional indexes yet. So here's the first query. Select star from DBO users. Now, you don't have to be a Microsoft Certified Master to figure out that your execution plan for this, I want you to build these in plain English, your execution plan for this is to just read out all the records. It doesn't matter what order you grab the pages from, anything will work. Maybe I've got some in memory, maybe I have to grab others off of disk here. That's how I like to think of my table in front of me, is that's where my storage is. I'm just going to shuffle through them in whatever order happens to be available. This is why order is not guaranteed. It's just whatever pages I happen to run across and grab, I'm going to put them in there. So here's what SQL Server's execution plan looks like. And throughout this course, I'm going to be showing you actual and estimated execution plans, jumping back and forth when it suits my needs. You see 3 tabs here. The execution plan is the third one. That means I ran a real query, got results back, and here's the actual execution plan. SQL Server started with a clustered index scan. It scanned through all of the data and dumped it back out through the select. Pretty straightforward. Could you parallelize this? If this was a big stack of paper, and believe me it is for a Stack Overflow, if this was a big stack of paper, could I break this work into a lot of people? Sure. Order isn't guaranteed. I could give one person 100 pieces of paper, another person 100 pieces of paper, another person 100 pieces of paper, and you could all start work on this right away. It's going to be an interesting concept as we move forward. Not all queries can be, and not all parts of all queries can be. Next query that we're going to run across. And as I go through and change things inside these queries, I'm going to color code the parts that I just changed. I'm going to try and keep building atop the same query. So instead of selecting ID, now I'm just going to get ID back. Instead of selecting star, I just want to give you ID. But I only want to get them where the last access date is greater than 7/1 of 2010. How are you going to accomplish this query? What you're going to do is you're going to scan through all of these pages, looking at that last access date column, and only saying out loud the IDs that are greater than 7/1 of 2010. Now, I'm kind of cheating here. I'm giving you a spreadsheet. That's not actually how SQL Server stores data. It crams the data in as tightly as it can on a page. There's no concept of reading down a page to see one column's results. Instead, SQL Server has to roll up its sleeves and go, all right, I'm going to bust open every row on this page and I'm going to figure out where the last access date field is and check that. Just want you to keep in mind that just because it's a column doesn't mean it's easier to sort. SQL Server still has to figure out where that data is. So if we look at the execution plan for it, it looks identical. I have just a clustered index scan. So here's your first kind of heads up that execution plans at just first glance don't tell you everything you need to know. Sometimes you need to dig a little deeper. And you can start getting a little deeper if you hover your mouse over parts of the execution plan. Now I've got the 2 queries side by side here. On the left, I've got the select star with no filter. On the right, I've got just the select ID where last access date is greater than 7/1 of 2010. What I've done here is I've hovered my mouse over the select part of the execution plan. And I get something called estimated subtree cost. A long time ago in a galaxy far, far away, that meant the number of seconds that the query was going to take on one machine in Building 35 at Microsoft headquarters in Redmond, Washington. Trivia over. Today, it doesn't mean anything like that. It's just a rough measure of CPU and I/O costs for a query. It's not really useful to compare 2 boxes to each other, like which SQL Server is going to run the query fastest. It's really only useful for comparing 2 queries on the same server. Spoiler alert, it's not good for that either, but more on that later. But if I hover my mouse over those, I get the same estimated cost. What I want you to take away is that it's not necessarily that much work to filter the data if I already have to crack open every single page and figure out where all the contents are, which I had to do anyway for a select star. And even though I'm returning less data, I'm only reading back the ID, that doesn't mean it's dramatically easier for SQL Server. Another way that I can see this is to use a parameter called setStatisticsIO_on. When I run this in SQL Server Management Studio, every query from that point forward inside my session, this only affects my own queries, just the one window I have open, will also return in the Messages tab the number of logical reads I have had to perform. Logical reads means the number of 8K pages that I've had to look at. The more, the less merry. Definitely not the more, the merrier. I want to keep this down as low as possible when I'm doing performance tuning because I don't want to touch any more pages than I have to. I am lazy. Well, if we look at these two queries, both of them show the exact same number of logical reads because you only have one copy of the table right now. SQL Server had to scan the whole thing. Now notice that set statistics IO on, easy for me to say, also returns something called physical reads. Don't worry about that. That technically means the number of pages that SQL Server had to get off of disk instead of just getting out of memory. But here's the thing. You can never predict which pages are going to be in memory at the time your query runs. Don't try and tune for lower physical reads. Try and tune for less logical reads, which is just the total of pages we had to read, regardless of where they were, in memory or on disk. I just want to touch less pages altogether. One of my takeaways here is that filters aren't necessarily that much more expensive. Even though sometimes SQL Server says, hey man, I wish I had a missing index, or I wish I had an index for this particular query, doesn't mean it's working harder, just means it could work less if we had this filter plus an index. No indexes for you then, though. Next query I'm going to give you. Same one as we had before, but I've added order by last access date on there. So think about how you're going to accomplish this in plain English, but remember, you're not a server. You're a human being with a big stack of papers in front of you, and you have to do this work. And you're not that bright. What you're going to have to do, just like me, is you're going to go through and find all of the records that match, but then you're going to have to go write them down somewhere. You and I, we are not bright enough to remember all of the records that came back, every ID and last access date. We're going to have to write them down somewhere and then sort them. We're going to need to build a list. The more data that we have, the more work is going to be involved. There's an interesting question there, especially for developers. When do you do the sort? Do you sort while you're writing or afterwards? Well, really, let's look at how SQL Server does it. First off, it goes through and does this scan, writing everything down, and then it turns around and does a sort. This has interesting impacts on parallelism, but more on that in a second. So let's compare the two queries. On the top is when we didn't have the order by. We just have a select ID for where last access date is greater than 7/1 of 2010. On the bottom, we've added the order by, and look at the difference there in estimated subtree cost. More than 10, my math is not so good. Less than 10 times more expensive. See, this is why I'm not a developer. I'm no good at math. So, man, that sucks. That actually really sucks. 10 times more expensive just to do a sort, but you'll notice there's nothing about parallelism inside that query plan. What if SQL Server does parallelize this? Because it can choose whether or not to parallelize stuff based on things like our server settings for max stop and cost threshold for parallelism. In some cases, if SQL Server does choose to parallelize this query, exact same query here, but in this case, SQL Server decided to parallelize it because I fixed the server so that it would. Now suddenly, my cost drops from like $250 down to around $150. Goes down by, I was going to give a number there, but we both know I'm not good at math, so we're going to say a lot. Right? That's fair. And if we look at set statistics IO, so this is what tells us how many reads we did, the number of logical reads isn't all that different because we still had to scan through roughly the same amount of pages. But notice the scan count is different. We did 5 scans this time because SQL Server broke the work out across more logical processors. I have more cores on my machine, so SQL Server said, all right, let's get down to business. Let's pass this work out across 4 or 5 people and get to work. Next query that we've got, I've only changed one thing. I've changed it to select star. Now, how are you going to build this query? Does it change anything about how you built it from the last one? You're going to do it the same way. You've only got one option. This is the only copy of the table you have. that query is going to suck pretty bad if you think about the work that it's going to actually take to pull it off. Does it take more time to read? No, not really. If we look at the estimated or the set statistics IO from this thing, it's the same number of logical reads. Up at the top, I'm doing just the select ID, but the second query down, I'm doing select star. Same number of logical reads, but notice down at the bottom, now I have a work table for the second query. We had more data than SQL Server could have gotten cached in RAM, and SQL Server decided to go out and start scribbling this stuff down somewhere into a work table. Because I've got a lot of data when I'm including the About Me field, which is this big, ginormous varchar max. I certainly can't remember that, even on a SQL Server with lots of RAM. I could have all kinds of data come back from that. And the amount of data that's going to come back, we'll talk about in our statistics modules, how that impacts how much query memory you get. So if I look at the execution plans between those two queries, the first one just does the ID. The second query does the select star. So notice that the sort is 74% of the cost of the first query, and it's 97% of the cost of the next query. In order to really figure out how ugly it is, we have to start hovering our mouse again in the execution plans. So in the top one, query went parallel, cost us about 150, but when I added in the select star, look at that query cost. 13,000, or crappy Brent math, around 100 times more expensive in order to do the select star. Let's break this down to make it just a little bit more obvious. I've got a grid here, depending on whether or not I'm doing just the select star versus the select ID, and whether or not I'm adding an order by. Look at the costs start to skyrocket as I add in an order by, especially with more fields. Because SQL Server has to scribble all of this data down somewhere and then sort it and then say it back out to the end users. When I was a developer or a database administrator, I thought that the big cost was just saying all of those fields out loud, the big long About Me field. Man, that is nothing compared to the cost of writing all this data down and sorting it. That's where the real work is. And that's where your takeaway is for this. I get it. Ordering by in the database is really, really easy. You just type order by and the magic happens. And we think that the fastest box in the house is usually the SQL Server. And often that's true. But it's really hard to scale out SQL servers to handle sorting because we don't have an easy way to scale out multiple SQL servers when we need real-time data. It's really easy for us as developers to scale out app servers. So unless I'm doing a top 100 or top 1000 in my query, I want to rip out the order by. Often when I'm doing query tuning, I'll just take out the order by and look at the cost before and after to see how much different it is. If it suddenly runs 100 times faster, there's our answer. Move that data out, get it out to be sorted over in the app tier. And I know what developers often say, but my app server doesn't have much memory and it's not very fast. Okay, let's fix that, because it's way cheaper to fix that than it is to bulk up the SQL Server CPU power. SQL Server Enterprise Edition is $7,000 a core US. $7,000 per core. That buys a whole lot of application servers as we have to start farming out additional cores. So let's recap what we've talked about here in this first module. First off, the clustered index, it may only be on one or two fields, but it has all of the fields in the table. In later modules, we're going to talk about non-clustered indexes and how you pick and choose the right fields for those. SQL Server stores not only just our clustered indexes, but our non-clustered indexes as well on 8K pages. Now, this starts to change a little bit when we get into SQL 2014's newer features, like Hackathon, for example, that stores the data completely differently. But for old school conventional tables, this is how it works. We also end up grouping them together into multiple pages, or multiple groups of pages called extents, and we'll tackle that later as well. DBCC IND and DBCC page let you see the actual page content so you can go spelunking around in your database. Now, warning, I'm not a fan of using DBCC commands on a production database, especially things where I'm just curious about page content. Do that over in development just so you don't worry about messing things up. Off-row data is a little bit different. Things like varchar max, file stream data, file table data, that's too big. We do still store it in 8K pages, but on lots of them, and we have to daisy chain those together. If you want performance, avoid putting those in here. Maybe consider storing that kind of big data elsewhere. I'm not going to say another database platform, because SQL Server does work for big fields. Just throwing that out there. And filters aren't necessarily more expensive, but ordering in the database definitely is. The more fields that you select, the more problems that you have. So join us over in the next module where we start talking about non-clustered indexes. If I'm going to continuously query by last access date, how about I build a copy of the database that looks like that and see how those query plans start to look?